Imagine sitting at your desk when your computer suddenly overrides its volume settings, blasts a deafening explosion, and deletes every file on your system. This execution sequence only triggered under highly specific conditions. The malware checked the victim's IP address. If they were located in Israel or Iran, it rolled a digital six-sided die. If the system landed on a 2, the machine was completely wiped. For everyone else, the virus held their data hostage. It sat quietly in the background, pinging the infected system every 60 seconds. If the victim noticed the breach and tried to revoke their API tokens to lock the attackers out, the malware instantly triggered the self-destruct sequence. Deleting the malicious files didn't work. The payload buried itself inside the configuration files of VS Code, a text editor used by millions of developers, ensuring the virus would reinstall itself the next time the application booted up. This wasn't a randomized phishing scam. It was a targeted, systemic takeover executed by an 1,100-member Russian hacking collective that had already breached several major security firms. The infection started at Tanstack, a massive open-source JavaScript library relied upon by thousands of web developers to manage data and routing. From there, the infection jumped into the internal systems of Mistral AI, a major player in the global artificial intelligence sector. To understand how this attack bypassed the security of elite tech companies, we have to look closely at the automated pipelines that physically assemble the software we use every day. The hackers began by submitting a malicious code update, known as a pull request, to Tanstack's public repository on GitHub. Open-source projects automatically route new code into a locked, isolated testing box to prevent core system interaction. But Tanstack used a parallel process to check file sizes. This bypassed the secure sandbox, accidentally exposing an internal authentication token to the malicious code. By exploiting this automated efficiency check, the hackers gained full write access to the project's central code repository, allowing them to sign off on their own malicious code without further review. With write access secured, the hackers could have rewritten Tanstack's code immediately, but altering the main files would trip internal alarms. Developer tools save time by pulling external code from a fast-access local cache folder. The hackers secretly injected malware into this local cache. When Tanstack ran an official update, their automated system unknowingly pulled the hidden malware from the cache into the official release. The hackers didn't have to break down the door. They forced the victim's own tools to assemble the threat from the inside. Once the virus was inside Tanstack's official release, it generated an NPM publish token, the credential required to push software updates to the entire world. These tokens expire in 10 minutes. To beat the clock, the hackers used an automated script to fire over 40 infected packages in just 6 minutes. The infection jumped to Mistral AI when an employee updated their local developer tools, unknowingly bringing the poisoned Tanstack packages onto their corporate machine. The virus then scanned the machine, stole the employee's Python tokens, and began publishing new malware under Mistral AI's official trusted name. This recursive spread mimics the Shy Halud, the massive sandworms from Dune. Like the worm, the attack burrows from one host to the next, growing larger as it consumes each trusted system. Trace logs reveal that GitHub had previously warned Tanstack that their automated testing method was exposing their security tokens. The warning was ignored because fixing the vulnerability would have slowed down their automated workflow and delayed their release schedule. Software teams are caught between the speed of automation and the friction of security. In this case, the project prioritized convenience, leaving a critical opening for the attackers to exploit. With the rise of AI-assisted coding and even faster automated builds, the scale and velocity of these supply chain attacks will only increase. The global software supply chain is built on these automated interactions. This attack proved that our digital infrastructure is only as secure as the